What is unconformity in geology? In geology, an unconformity is a significant break or gap in the geological record, representing a period of erosion, non-deposition, or deformation that separates younger rock layers, strata, from older ones. Unconformities are crucial markers for understanding the Earth's geological history as they signify periods of geological activity and environmental changes. They provide evidence of past tectonic movements, changes in sea level, climate fluctuations, and other geological processes. Unconformities occur when there is a discontinuity in the deposition of sedimentary layers. Sedimentary rocks are formed over time through the accumulation and compaction of sediments, such as sand, silt, and clay, which settle in layers on the Earth's surface. However, geological processes such as erosion, uplift, or subsidence can interrupt this process, leading to breaks in the sedimentary sequence. These interruptions create gaps in the rock record, which may range from thousands to millions of years. How is unconformity formed in geology? Unconformities in geology are formed through a combination of geological processes that interrupt the continuous deposition of sedimentary layers. These processes can occur over vast spans of time and are driven by various factors such as tectonic activity, sea level changes, climate fluctuations, and erosion. Understanding the formation of unconformities requires examining the sequence of events that lead to breaks or gaps in the sedimentary record. Tectonic activity. One of the primary drivers of unconformity formation is tectonic activity, which includes movements of the Earth's lithospheric plates. During tectonic events such as mountain-building processes, orogeny, the Earth's crust can undergo uplift, folding, faulting, and tilting. These movements can disrupt the horizontal layers of sedimentary rocks, leading to angular unconformities. When younger sedimentary layers are deposited on top of these tilted or folded older rocks, an angular discordance is created, indicating a period of tectonic activity followed by erosion. Sea level changes, fluctuations in sea level also contribute to the formation of unconformities. Changes in sea level can result from factors such as glacial cycles, tectonic movements affecting the configuration of continents and ocean basins, and changes in the volume of water stored in ice caps and glaciers. During periods of sea level rise, marine environments expand and sediment deposition occurs, building up layers of sedimentary rocks. Conversely, during periods of sea level fall, erosion can occur as coastlines retreat, exposing previously deposited rocks to weathering and erosion. These erosional processes create gaps in the sedimentary sequence, known as disconformities. Climate and weathering. Climate variations influence the rate and intensity of weathering and erosion, which can contribute to unconformity formation. In regions with arid or humid climates, weathering processes such as freeze-thaw cycles, chemical weathering, and mechanical erosion, e.g., wind and water erosion, can break down rocks and remove sediment. This erosion can lead to the removal of previously deposited sedimentary layers, resulting in unconformities. Depositional environments. Changes in depositional environments, such as shifts from marine to terrestrial or vice versa, can also create unconformities. For example, the transition from a marine environment to a terrestrial environment may involve the retreat of the sea and the exposure of marine sediments to erosion. Similarly, the shift from a terrestrial environment to a marine environment may involve the deposition of new sedimentary layers on eroded surfaces, forming nonconformities where sedimentary rocks overlay older igneous or metamorphic rocks. Overall, unconformities form through the interplay of geological processes that disrupt the continuous deposition of sedimentary layers. By studying unconformities, geologists can reconstruct past environmental conditions, decipher the history of tectonic events, and gain insights into the dynamic nature of Earth's geology over millions to billions of years. Unconformity types. Unconformities are classified into several types based on the nature of the discontinuity and the relationship between the older and younger rock layers. Each type provides valuable insights into the geological history of an area and the processes that have shaped the Earth's surface over time. Here, we'll delve into the three main types of unconformities. Angular unconformity. Angular unconformities occur when younger sedimentary layers are deposited on top of tilted or folded older rocks. This type of unconformity represents a significant interruption in the sedimentary sequence and indicates a period of tectonic activity and uplift followed by erosion. The older rocks are typically inclined or deformed due to past geological events such as mountain building processes or tectonic movements. Subsequent erosion wears down the tilted or folded layers, creating a flat surface on which new sedimentary layers are deposited horizontally. The angular discordance between the older and younger rocks is a distinctive feature of angular unconformities and provides evidence of the geological forces that have shaped the landscape. Disconformity. Disconformities occur when there is a break in the sedimentary sequence between parallel sedimentary layers. In this type of unconformity, the older and younger sedimentary layers are both horizontal, but there is evidence of erosion or non-deposition between them. Disconformities are often more subtle and challenging to identify compared to angular unconformities because the layers above and below the unconformity may appear similar in texture and composition. However, careful examination of sedimentary structures, fossil assemblages, or changes in lithology can help geologists recognize disconformities and interpret the depositional history of the area. Nonconformity. Nonconformities occur when sedimentary rocks are deposited on top of older igneous or metamorphic rocks. This type of unconformity represents a transition from erosion of the underlying hard rocks to the deposition of sedimentary layers on top of them. Nonconformities are significant because they provide evidence of uplift and erosion of older rocks followed by the deposition of new sedimentary layers. The contrast in rock types, e.g., sedimentary over igneous or metamorphic, and the absence of intermediate sedimentary layers indicate a period of geological activity and landscape evolution. Nonconformities are commonly found in areas where ancient mountain ranges have been eroded, exposing crystalline rocks that are subsequently covered by sedimentary deposits. In addition to these primary types, there are variations and combinations of unconformities, including paraconformities, where there is a subtle stratigraphic gap with no obvious erosional surface, and unconformities associated with volcanic or glacial activity. By identifying and studying unconformities, geologists can reconstruct past geological events, interpret changes in depositional environments, and unravel the complex history of Earth's surface evolution. Unconformity examples. Unconformities are widespread features in the Earth's crust, and they provide essential clues about the geological history of a region. Here are several examples of unconformities from different parts of the world. Grand Canyon, USA. The Grand Canyon in Arizona is renowned for its spectacular exposure of rock layers spanning millions of years of Earth's history. One of the most prominent unconformities in the Grand Canyon is the Great Unconformity, which separates ancient Precambrian rocks from overlying Paleozoic sedimentary layers. This angular unconformity represents a significant gap in time, with Precambrian rocks dating back over 1 billion years overlain by much younger Paleozoic rocks. The erosion and tilting of the Precambrian rocks followed by the deposition of younger sedimentary layers highlight the dynamic geological processes that have shaped the canyon over millions of years. Siccar Point, Scotland. Siccar Point, located on the Scottish coast, is famous for its remarkable angular unconformity, first observed by geologist James Hutton in the late 18th century. At Siccar Point, vertically tilted Silurian sedimentary rocks are overlain by horizontally deposited Devonian sandstone layers. This stark contrast between the orientations of the older and younger rocks provided Hutton with evidence of the concept of deep time and the cyclic nature of geological processes. Siccar Point is considered a foundational site in the development of modern geology and is often cited as an iconic example of an angular unconformity. Joggins Fossil Cliffs, Canada. The Joggins Fossil Cliffs in Nova Scotia, Canada, contain a wealth of fossilized plant and animal remains dating back to the Pennsylvanian period, about 300 million years ago. Within the sedimentary rock layers exposed at Joggins, there are numerous examples of disconformities, where erosional gaps interrupt the sequence of coal-bearing strata. These disconformities reflect periods of non-deposition or erosion during the formation of the coal-bearing sedimentary rocks, providing insights into the environmental changes and ecological dynamics that occurred during the Pennsylvanian period. Karoo Basin, South Africa. The Karoo Basin in South Africa preserves a rich record of sedimentary rocks deposited during the Permian and Triassic periods, around 250 to 200 million years ago. Within the Karoo Basin, there are several examples of nonconformities where sedimentary layers overlie older igneous and metamorphic rocks. These nonconformities represent episodes of uplift and erosion of the ancient landmass followed by the deposition of new sedimentary layers. The Karoo Basin is renowned for its fossil assemblages, including early dinosaurs, which provide valuable insights into the evolution of life during the Mesozoic era. These examples highlight the diverse nature of unconformities and their significance in understanding Earth's geological history. By studying unconformities, geologists can reconstruct past environments, decipher the sequence of geological events, and unravel the complex interplay of tectonic, climatic, and erosional processes that have shaped the Earth's surface over millions of years.